Hey, how's it going, Phillies and fellers? Brad the Guitarologist here. In this video, we're going to take a look at this mid-1970s Longines AM/FM clock radio. This thing has a flip clock, which has a bit of a problem with it. The radio also has a bit of a problem with it we're going to address. As you can see out there to the left-hand side, you'll see my old poor JVC camcorder that bit the dust recently. I had an issue with the mic jack, and I went in to try to repair that and ended up breaking one of the ribbon cables on accident, so that thing is pretty much toast. And while we're waiting for my new camera to come in, which is going to be a real nice addition to the channel, I believe, we're going to film this one with an older camera that I have. So if you can tolerate a few minor quality issues, please do stick around and check this out. I got this thing at a Goodwill for I think about $5 a long while back. I've kind of fell in love with the form factor of it. I like the little swivel base and everything. So yeah, let's see what we can do with this Longines clock radio. So over here on this side, we've got volume, we've got AM, FM, and AFC, and here's our tuning. But very cool. I mean, Longines is that's actually a luxury watch brand. Isn't that right? Aren't they Swiss or something? Or that kind of caught my attention when I first saw this. Like I said, I got it at a Goodwill. Well, two things actually caught my attention: the fact that it was a Longines, and the fact that it is a flip clock. Okay, so it's nighttime right now. Let's get a sweep of the AM band.
It bothers you when she's always talking to her friends, but her bubbly personality.
We got some dirty controls.
What should you do? Spend the rest of your lives irritated with each other? Of course not. Instead, you should remember and appreciate those things that first attracted you to your spouse. It is still unknown. Tonight we must, as a community, condemn the actions of the perpetrator. But most important, let's all come together. Smith, of course, going to go for the football. Just goes off his fingertips. About going back to last season, seeing ghosts. Just talking about came from that. That's the signal to reputation. Is the idea that anyone try to excuse this, the demonstrators? So the task of keeping that cleaned up so that the lower fuels on the ground cannot catch fire and actually cause a forest fire is monumental. It's a huge amount of manpower.
And you'll notice the clock hasn't changed since we started messing with this either, so it's definitely frozen. I can hear a little bit of low hum, and some of these stations sound like they have some hum in the background as well. So I don't know. We might have to change some caps up in this thing too. If we look at the bottom here, it does have a UL sticker, and also there's a model number and everything here, some information. Model LCR 444. There's a serial number. Feeling some vibrations from this thing just holding it. So I think we've got some power capacitor issues probably. In addition to whatever's wrong with the clock, so we'll definitely take a look at it. But I mean, it is easy to get into, it looks like here, so we shouldn't have any problems there. We have an earphone monitor right there. That's interesting. Okay, so this is Japanese. I was thinking this might have been from more like the Hong Kong era, but so this is 70s, I would say, probably early 70s, something like that. You know, it's kind of from the plasticky solid state radio era, but let's get that screw out right there and get the back off and see what we're dealing with in terms of components. Actually, before we do that, I forgot what we were doing. Let's finish up our sweep of the FM band. I've got the automatic gain control engaged now. We'll start over here on the low end. But do you see what I'm talking about? It kind of has that, it's kind of almost a square wave kind of feel to it. So I mean, I think it's definitely got some power capacitor issues. And just sitting here listening to it, I can hear the hum. I don't know if you'll be able to hear that or not, but I can hear it.
Possibly be life in the atmosphere around Venus. What? Distribution of the BBC World Service in the United States is made possible by American Public Media, producer and distributor of award-winning public radio.
That's just regular FM. Yeah, it's very buzzy sound. I don't think it's a matter of like a dead transistor or something, or you know. I think it's more likely. Oh wait a minute! It did move. It did move. It flipped. 11:59 now. It's only flipped once though.
I took a walk to clear my head.
And again, the strongest damn stations on the radio are the ones I least want to hear. Never fails. There's another example. Jesus. Fine. All right, yeah, so actually not many stations is coming in very well on this thing right now. The flip clock hasn't flipped again. So, I mean, I can flip it manually over here with this. I can set it, in other words, but so it moves. It's not completely frozen, but it's just not moving on its own. So that part needs to be cleaned. We'll take that apart. I'll show you how to do that. If you have a flip clock that's seized, usually it's just a matter of unseizing it and cleaning it and then lubricating it. So that should be easy enough to take care of, but we're also, sounds like we're gonna have to do some capacitors. So let's go ahead and unplug it and pop the back off. You gotta appreciate a design that one screw and you're in. it's like my kind of woman. I didn't say that either. I'll edit that out. You guys, you have to realize that I'm just joking when I say stupid shit like that. Oh, we've got a schematic in this thing. I'll be damned. Wow. Look at that. Okay. So check this out. This seriously, this is just one screw and you're in and everything comes out as well. This is kind of cool. I mean, first of all, check out the nifty little schematic down there. So that might come in handy, but I mean it's tacked to the inside of the housing rather than on the back. It would have been nicer if it was on a back here somewhere, you know, so you could take that back off and use it down there. But I mean, still, I mean, at least they gave you the thing. I mean, but look at the contrast between, you know, the culture of today, which is basically just, you know, use something up and throw it away, especially something that's as basically as cheap as this thing probably was, even new. You know, it wasn't that expensive, but because it was an import, it was Japanese, and Japanese stuff even back then was looked down on. I mean, now Japanese stuff we kind of revere because usually the build quality is very, very high, but at the time it was looked down on, Japanese stuff. But yeah, so the clock is by Wittenauer USA, and very interesting though, model LCR 444. You know, the contrast though is very interesting to me between, you know, the old and the new, the throwaway culture of the day and the culture of repair in the past, even for something that was probably as cheap as this. But also look at the ease of repair for this thing. So we've got one screw on the back that comes out, right? So that's already out. We've got knobs. We got 1, 2, 3, 4, I guess, if you count those two. 5, 6, and 7 knobs. So 7 knobs, 1 screw, and look at this. Look at this. The whole damn board is just going to slide out. Look at this. Okay, so here's the clock mechanism. And this is going to have to be cleaned first and then lubed. So this is going to I'm going to have to get this little housing off right here, the shield, and then we'll clean that regulator or governor or whatever you want to call it. If we pop a wire off, then we might get lost as to where it belonged. But like I said, I mean, look at that. One screw, and we have the whole thing comes out. It's amazing. You just don't see that kind of design anymore. It's really ingenious. The only thing I wish is that they had given me a little bit more wire to get this out of here even further. But it might be all right. Okay, so first and foremost, I think probably where's the all right, the power's coming in. I mean, this has got to be one of the main capacitors, surely. If not the main capacitor. But I will probably test this capacitor here in a minute. The couple of bigger ones for sure. I'd like to test those. But like I said, we'll have to go through this. Some of these transistors I know for a fact. Now I don't do a lot of radios, but what little I do know is these types of transistors with the little spaceship domes on them, those don't usually hold up very well. So that automatically is suspect to me. This is automatically suspect to me just because of the symptoms. So is this one here, because that's one of the larger capacitors in the circuit. Now I'm not sure where it is in the circuit, but I'm guessing it might have something to do with the power, just simply because of how large it is. Let's see, too. We got, all right. Now probably also the motor, or the governor up here on the clock kind of probably also acts as a choke coming in. And if it's not operating properly, it's possible that might introduce some noise. I'm not really sure on that. I think that has to do with an antenna right there. But yeah, just give me a minute here. We're going to just kind of look things over. I don't really see anything burned or anything like that down here. I do see some goop on some components, but that's not that hasn't been burned. Here's our loop antenna. So the signal comes in here for AM. I definitely don't want to go tweaking on anything without knowing what everything is first. They have a listing for this model on the Radio Museum website, but it doesn't have any schematics. This schematic is so small, there's no way you can make out anything unless you do this, and maybe I'll get lucky and it'll be legible enough, but I don't know how much it's going to help me anyway, to be honest. But we'll see. Anyway, but there's if anybody's looking for the schematic for this, there it is. You just gotta hope the resolution is good enough to be able to use it. Okay, so we can listen to a bit of Rafe Vaughan Williams here while we check this out. You can hear the distortion in this, or I hope you can. That's me just bridging over that main capacitor with this 100 microfarad. I can't even read what's on that capacitor. I think it's supposed to be 100, but that's all I'm doing right there. There we go. picks up the output as well. So I think yeah, I'll go ahead and replace that for sure. Probably that second larger one as well. And that's my guess is that's going to help with the tone of this thing a lot. And also the reception, because a lot of these stations just aren't coming in like I would expect. Like, let's take that one for instance. It's like 10 times better. Like that one, there's almost nothing there except for just some buzzy music. But that definitely brings it in and helps out a lot. So yeah, definitely I'm going to swap out the larger capacitors and maybe any others that I see that are a bit suspect. But this thing is actually full of, I would flip it back over and show you, but it's on. But this thing is actually full of those little spaceship shaped epoxy transistors. And the one that I showed you earlier was actually a diode, and not, I didn't even realize it, but it's a diode. It measured okay, so I think that one's fine, but this thing is full of those crappy transistors. So I think the game plan here, I'll swap out some of the capacitors to try to get the radio working a little bit better, and then because it does work, it just doesn't work that well, and it definitely works a hell of a lot better even with just that one capacitor. So on Radio Museum, they do have a listing for this radio. This is a really good website, man. If you do this kind of stuff and you don't have all the SAMs on hand at the ready, I've got a lot of really old schematics and writer's manuals, but I don't have a whole bunch of SAMs like a lot of people you'll see who do this a lot. Yeah, but you can go to this website a lot of times and get schematics for just about everything. But in this case, they don't have a schematic. They just got 3 pictures of the unit. They're guessing, about like I did, that it's mid-70s, 1975. Longines Symphonette. What do they say about it? Not a whole lot. Wittenauer LCR 444 is the model. Modern plastics, no Bakelite, yada yada yada. It must be fairly rare, because usually if you see stuff like this, you'll find all kinds of photos if it's if there are a lot of them out there. But it looks like maybe there's only 2 or 3 of them on the web that I could see. Apparently they did make a lot of flip clocks around this time, because I'm seeing some other ones here, some different styles. That one looks especially cool. With, I don't know what that is. That's a light sticking up. Then you got a flip clock over here and just this weird funky thing. This one's kind of cool too. Same sort of principle. You got a clock and this weird funky thing standing up. Here's a better shot of that. But it looks like they did make some other styles. Hopefully this will do for now. Oh my God. Look at that. Oh, no wonder. Shit. Yeah. Look at that. So this leg just came off. So it was corroded. So this is actually supposed to be 1,000 microfarad at 16 volt, and I was using 100, and even the 100 was bringing the tone way out, really improving it. So yeah, well, let's get the correct, we'll get the correct value in here, and that should really wake it up. It looks like maybe they used some adhesive that got corrosive over the decades and just kind of took out that leg completely. So it wouldn't surprise me if one of them is like that. There's probably more, but you can see what I mean about this component here. That's a diode. This one over here, you can see down in there, there's one of those transistors. There's another one over here, one of those little spaceship looking things. There's another one right down in there. There's another one over there, another one there. So this thing is full of those little epoxy transistors that are just not very good. Those things have a bad reputation, real bad. But yeah, let me find a 1000 microfarad capacitor and we'll get the correct value in there, and this thing should wake right up. I'm gonna go ahead and replace this one as a matter of course as well. Okay, so there's that in there, and I have a sneaking suspicion that's going to wake that thing. That's going to wake this thing right up. But let's go ahead and actually replace that other capacitor though too. Okay, so there's a shield over here. Unfortunately, that the other capacitor I wanted to replace is a 470 microfarad at 16 volts, but unfortunately the leads are under this little shielded area right here, and I don't see how to get that off of there. Oh, it's soldered on right there. I think it's just stuck through up here, but I think it's twisted around. I think I'm probably going to cause more damage than I'm going to do good if I try to get that off right now, because any one of these little wires gets broken and I probably will never figure out where it went, unfortunately. Yeah, I think let's just try it with the new capacitor in right now, just like it sits. Let's see how.
Nigerian nurses and midwives, welcome.
Well, it's definitely a lot clearer, a lot better. I still don't think it's perfect though. I think if I could replace that second one, I think we'd be better off still. Let's try AM. AM's dead now. What the hell? Why is AM dead?
So great, but well, we will, you know, so when it comes to live events, of course, the health and well-being, that's number one of anybody, and we've all been going through some times. Well, current restrictions in the state of Washington have left us no choice but to reschedule our live show. It's at the historic Everett Theater. It was scheduled for 6.
Oh shit, look what I did. Look what I did, look at this. You see this is bulging out on top, the new capacitor that I just put in. You see how it's bulging on the top right there? And this sucker is hot. And I can actually smell it. I can actually smell it burning, cooking on the inside. So I put it in backwards. So I screwed up. I don't know how I did that, but I guess I did. So the lead that was cremated was on this side, and that was supposed to be the positive. That's the negative on the other side. So I've got it in backwards. So yeah, let's yank that one out and replace it with another one. Whoops. Okay, so here we are with the little shield off of this piece, so we can get a little better look at what's going on here. So what we have is we have the line cord comes in. So here's the line cord. So it basically comes in right here. So we've got a wire nut. One part of it takes off and goes over here to this transformer, or to this winding, and the other part of it takes off and goes over here to the transformer. This transformer will step down the voltages that will be used in the radio to 16 volts or whatever, 12 volts or whatever it is. Or that might even be 11. I think it says 11. No, 9 volt right there. And the measurements that I took, I think it was 9 volts. I did go ahead and measure across that capacitor when I changed it, just to make sure it wasn't being overvolted, and that's why the other one blew up for whatever reason. But no, I definitely had it in backwards, and it was actually bulged at the top and the bottom. That thing was about to explode probably. So that was pretty dumb. But so yeah, we've got the 120 volt, 60 hertz, 60 cycle coming over to this winding. Now this winding induces a 60 cycle voltage over here in this device, which basically will spin around at 60 cycles. So, you know, there's 60 seconds in a minute, you know, 60 minutes in an hour. And fortunately, our electricity in the United States is all 60 hertz. So they can actually regulate a clock just based on the cycles per second of the voltage coming out of the wall. So this thing spins around, it'll tick that little arm down inside of there. The little arm will tick this over, and when this ticks over enough times, like so, eventually it will come around to the point where that little nub right there hits this and flips this over, and that regulates this next wheel, and the next wheel does the same things, and so on. So what we're missing is essentially this piece right here is not doing its job, and the reason it's not is because it's all gummed up inside. We have to take this apart. So to get it apart, we're gonna have to remove those two nuts back here on the back and take this whole piece out, and then that should free that piece up so we can basically, hopefully, take it apart and soak it in something, probably some alcohol. We can see here, actually, this might be worse than I thought. You see that crack in that little regulator wheel right there? That could be bad. The flux field that's being set up here, it's being induced by this coil, and the field is being induced into this, and inside of this is the regulator. But the problem is, I don't know if we're going to be able to fix this or not. This is okay. See, 1 RPM, so 1 revolution per minute, 60 hertz. This is what we need to fix, but I don't know if we're going to be able to fix this or not, man. I wonder if I could find this part online. That might be the easiest way to go, because otherwise, what I'm going to have to do is probably somehow melt or scrape away this adhesive around the edge and gently lift this off of here. But I'm also going to have to take this plastic bit off of this this shaft, and I don't know if I'm going to be able to do that without either A, breaking the plastic bit, or B, breaking one of the gears inside of here. So we've got an issue here with this piece. Let's look online and see if we can find something like this. Omron. We need a 1 RPM, 60 hertz regulator. All right, the other thing I probably need to go ahead and do before I go any further is measure this coil to make sure this coil is continuous. The problem is, over here, if we follow this back, we've got that transformer over there in parallel with it, so if I try to measure it as is, it's just going to be measuring this. So I need to desolder one of the leads on this so I can make sure we're just measuring this coil. 1.7 K. That's at least it's continuous. We know it's continuous, so that's good. Last time I had this problem of one of these 1 RPM motors not working correctly. The solution is to soak them in alcohol, and basically a little bit of the alcohol will seep down in through the shaft opening right there. So I've just let this soak now for, I don't know, probably 3 minutes, 4 minutes, something like that. It's been in here. But now, instead of being completely locked up, actually, let's see if I can get it going. It'll actually turn freely now. it is locked. It's locking back up at certain points too. So it's almost like, I don't know, it's almost like there's some gunk still in there, but see, it'll start to go freely now, and I can, obviously I can feel there's some gears inside of there that help regulate things, and probably what's happened is whatever lubricant they had on those gears, over the past, whatever, 45 years or 50 years has, gummed up. And see, it stopped again right there. So you can get it going at points, then kind of if you stop at certain points, it will stop too. So yeah, really what I need to do is just let it keep soaking. Okay, so after searching pretty much all over the internet to try to find one of these little motors, I did happen on eBay, and I checked out the listings there, and I did find this motor, which is a synchronous motor. It'll operate at 50 or 60 hertz, either one, depending on where you are in the world, depending on what your wall, the frequency is at the wall. It'll run on AC 100 volts up to 127 volts, so that covers a little bit of a range there. Handles 4 watts, and it'll run at 0.8 RPMs or 1 RPM, depending upon, obviously which hertz setting your wall voltage is at. So if it's at 50 hertz, it should be 0.8 RPM. If it's at 60 hertz, it should be 1 RPM. It'll run in counterclockwise or clockwise, which means you should be able to reverse the polarity and get it to run, either or. And the thing is, the best of all, the thing is under $10. It was like under $9 actually shipped. I did find this one also, which is it's almost exactly like the one that I had in this unit. It's a Tamura though, but this one should be 1 RPM as well at 60 hertz, made in Japan. But the thing is, this one's coming from Canada, and they wanted 20 Canadian dollars, which is about 15 US dollars, and they also wanted about 15 US dollars to ship the thing. So that's like $30 for this little part, and it's just, $30 versus $9, it's obvious which one I was going to go for. It doesn't necessarily work out the way that I'd hoped, but check this out. Okay, so I've got my new camera in, which is what we're looking at right now. I've also got the new part in for this project. This is a 1 RPM motor, but the problem with this, and it's at 60 hertz as well, it'll run at 50 hertz also, but if you run it at 50 hertz, it's only a 0.8 RPM. So anyway, this is way, way bigger than I thought it was, just by looking at photographs. Now that'll teach me to just order something without really paying close attention. I just saw that it was cheap, it was 1 RPM, and I assumed it was a smaller motor than this. But it's not. It's pretty large. But what I'm going to have to do is, I think it will mount in here. I think the size can work, but I'm gonna have to come up with some creative method for mounting this, and I haven't really quite figured that part out yet. But I'm also going to have to probably remove this little plastic piece off this old motor so that I can transplant it onto this. I may even have to cut this down slightly, I'm not sure yet. But there's definitely going to need to be some modifications here to this thing to make it work properly. And I haven't really quite figured that part out yet. But I think definitely what I want to do is get this off of here. And I think I might have to grab a little saw, little jeweler's saw or a hacksaw or something, and just chop it off, because I don't want to break it. And basically epoxy glue it onto the end of this so that it will do what it's supposed to do. What happens is there's this little ramp here that will push this little arm in. So I'm gonna definitely need that or something like it. Definitely need to mount it on here somehow. I've got to find a way to jack it up off of here, so I'm gonna have to probably mount another plate or something onto here. maybe I can use some of these pieces of the shielding that was on here before, so I might find a creative way to use those. Okay, so what I'm looking at is this is going to have to kind of rest more or less right here on the edge of this. The other piece will be glued onto it and will spin around and tap this forward. But it pretty much needs to be in contact with it at all times, kind of holding it in this position until that one piece comes around, and then it'll kind of click it forward and it'll click the clock over. So it'll have to be mounted kind of like this, but you can see it's kind of cocked upward, so I have to boost this back up slightly. But I think what I can do here is get like this little bracket like this, and so what I would do is have this up underneath it, and then this would screw into that. So I might be able to either cut this off or flatten this out so it'll come across here, and then I can bolt it also to the frame. But that's kind of the idea at the moment. I'm just kind of still brainstorming about this, but I also wanted to get some shots here because I want to just check out this camera, and you guys, I'm sure, will be able to see at least this is pretty good picture quality. The microphone also should be pretty good. I've using my overhead now, and this thing has the microphone input, so that's one of the major requirements. Also, this thing has a built-in gimbal, so it really, if it starts to shake wildly, it should, you know, stabilize to some degree. Like if I shake the table, like a lot of times I'll accidentally hit the table or something, and it'll transfer into the camera. But now I can shake the table a little bit, and it's not that big of a deal. The internal gimbal will kind of stabilize and take care of that. Oh shit. No, stop! 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 Oh, fuck. Man, it is so close. that's actually working very well. Oh, it doesn't like that at all. Shit. Sometimes it'll work one way, sometimes it'll work the other way. There's no predicting which way it's going to go. I think it just depends on which direction the wave is moving first when you make contact. It's a crapshoot which way it's going to go. It's just not. All right, so let me see. It was working perfectly going this direction. What I want to do is kind of split the difference. I want to make it work both ways. I don't know if that's going to be possible or not. Okay, so I'm going to unplug it and I'm going to replug it and not change the polarity at the switch. See? I did it a couple times and got it to go the other direction without even reversing the polarity at the switch at the plug. So, I don't know. Well, that way works smooth as silk. If I could guarantee that it would go that direction every time, that would be nice. But it doesn't seem to be something that I can guarantee. Let's unplug it again. And we'll plug it same polarity. Okay. I think once you get it going one direction, it's like the gears inside are, I don't know, it's constructed in such a way where it could go either way. So what I want to do, I want to make one more pass here, and then I'm going to reverse polarity at the plug, because when I do reverse polarity, sometimes it usually will change it, but it's not predictable. But that's working like a charm right there. Okay, so I'm going to go ahead and reverse polarity right now and bring it upward. Yeah, see, it does work that way, but it's a lot clunkier. All right, there we go. It's just made in China piece of crap, and it's not really, I don't think it's made to be that precise. Whoop. Well, it passed at that time without flipping it. But it passed it way before the minute was up. So, yeah, we've definitely got a fast motor here. And that really sucks because of all the time I just spent trying to get this damn motor. I mean, I finally got it installed. I finally got, you know, everything set up and calibrated the way I wanted it. I put this little screw in so I could calibrate the throw of the arm. You know, all this little fiddly crap that you have to do to get it to work right. And then come to find out that something basic, like the speed of the damn motor, is throwing you off. So I'm going to get my money back on that, because that is wrong. Okay, so we've pretty much reached the end of the road with this thing, at least for the time being, until I can get an actual 1 RPM motor for this to regulate the clock. So anyway, there's that thing, this Longines Symphonette Wittenauer clock monstrosity that I've spent far too much time on. That's kind of what we do sometimes on this channel, spend way too much time on crap that we should have just thrown away to begin with. So anyway, there it is. See y'all later. Take care.